Following on from the previous video, we got to this stage here where we were trying to find out the area of this, and the way we find the area is by summing up all the slices, from 0 to b, and as we sum up all the slices, we are moving in the y direction, and then each step of the way in the y direction, we need to know the x length from here to here. From here to here. So as we're moving in the y direction, we always need to know the x length from here to here. Well, this x length here, well, this here is the equation of the whole circle. But then if you rearrange it, if you rearrange it, it will give you this. It will give you x. So this here is our x length at each step of the way. Well, if you rearrange this, plus x squared to both sides, and then take away y squared, and then square root both sides, it will give you this. So this thing here is really the x length. This thing here is really the x length. As we move, as y is moving, as we're moving in the y direction, this thing here represents the x length from here to here. But then, so we got to this stage here, but currently our knowledge is not good enough to be able to integrate this. So we will need to change. We will need to change it to polar coordinates. By working in terms of theta, we can express the x length very easily by using polar coordinates. So by working in terms of theta, we can easily express the x length as we're moving along. You see the x length as we're moving along. So if currently this here is at an angle of theta, then the x length from here to here is a cos theta. Okay, so by working in terms of theta, we can easily express the x length as we're moving along. Well, the x length as we're moving along is a cos theta. So this length here is really the same as this length here, and then this length here is a cos theta. So as theta is moving about, we can easily express the x length. It's just simply a cos theta. So this is our x length. This is our x length. But when we're working in terms of polar coordinates, in terms of theta, this is our x length here. Okay. So this height here, by the way, is a sine theta. This length here is a cos theta. Okay, so this thing here becomes it becomes easier to integrate once we work in terms of theta. So now let's use substitution. So finding out the area. Well, the area is given by this. The area is also given by this. Well, the area is also given by this. But remember, we are now working in terms of theta. So let y, now we're going to use substitution. Let y equals this. If y equals this, then dy equals this. Okay, so now we can now we can put this. Sorry, hang on. So hang on. Let's go back one step. So the area is given by this. The area is also can be given by this, and it can also be given by this. So looking at this dy here, if we let y equals this, then dy equals this. But now we can put this into the dy here. So this whole area here becomes a cos theta. So that will become a cos theta, and then this dy here is this thing here. So basically we are going to put this into well, then this becomes this bit here. Okay, so this bit here is really this bit here, and this theta here is this theta here. And originally, so currently we are here at the moment. Put this into the dy, and then the whole thing here, will become this. Okay, I will continue in the next video.